Is the slides visible? Okay.
Ma'am.
Am I audible?
Yes,
Yeah. Is the slides
audible.
visible?
But slides is on the way to get it. We're
Okay.
starting to share the content message only, but I'm not getting the content.
Wait, I'll just share it again. Is it visible now?
No. Entire screen you had shared it. It may be,
Now?
yeah, visible.
Oh.
Make it a slideshow.
Yeah, fine. Yeah, the first presentation is from the Priyam batch. It's on the mathematics in engineering application. Students belong to computer science and engineering and data science. So I'll just hand over the session to them to continue the presentation.
Priya, make a slideshow button and that will visible.
No, I just made it. Is it not working now?
Is it? No. You click on enable editing, then make a slideshow.
Yeah. This is fine?
Yeah.
Okay. Yeah, if you start. Click is working. So if you just click, it's going with the slideshow mode. You can start. Can you start from there? I have to start from the beginning. Yeah, 1 minute. What happened? Is this visible, Maya, slides?
Yes, visible. Everything is just. We have icon next button. In that you can press it. Tell her to press that at the bottom corner.
Okay, ma'am.
Next.
Can we start?
Yeah, you can introduce your teammates and get start, Priya.
Okay, thank you, ma'am. I'll start here.
You make louder.
Okay.
Okay.
Am I audible, ma'am?
Yeah, audible. Little bit louder you can talk.
Am I audible, ma'am? Is it?
Yeah,
is it
yeah,
fine?
yeah. Good. Yeah.
You start. Life is like a mathematical equation. In order to gain the most, you need to subtract the negativities, and you need to know how to convert negativities into positivities. With these lines, myself, Priyam, from CSC Data Department, along with my companions, presenting a presentation, and I'm very privileged and thankful for the ma'am who has given us the opportunity to be here. So I'm starting, as we all know that the theme of today's afternoon is application of mathematics in engineering. So let's start with the presentation. First, we thought of introducing according to our slides. My name is Priyam and I am with Bhumika and Sara. We three are from CSC Data Department and will be going with the further slides. The very first question that clicks in everyone's mind is, what is mathematical engineering? It is the art of applying maths to solve the complex real life problems. Math is itself a very beautiful subject and is different from all others because it develops the logical thinking which makes us different from other streams. Maths have a wide variety, and it have a huge expansion in computer science engineering, civil engineering, and electrical engineering. In computer science, it uses logic, analytics, and all. In civil, we use trigonometry, geometry, and all. In electrical, it uses research operations. Mathematics, and we will be going with mathematics and computer science. By the word computer, it seems something that computes. Like everyone uses computer nowadays. If even if we have to make a mail, we go to laptop and we just see physical thing. But there is something like data and computation going on. This is our branch, data science, and we'll be handling in further sessions. Some of the applications of which are algebra, calculus, statistics, binary maths, and discrete maths. In the calculus, the general areas of use will be graphing and visuals, codings, applications to solve problems, binary calculus, and information processing. The most common examples of these are used in visual graphs, which are often 3D. These are the interest of nowadays people, like we're interested in making 3D graphs, presentations, and we have a huge job opportunities in these as well. Like computer graphics, image processing, optimization, and the newly introduced machine language and data science. Now I'd like to call Sara to introduce discrete math to the further slides. Thank you, Priyam. I am okay. Let me start. Okay, as it is rightly said that mathematics is not is all about creative thinking and not about calculations. Now I'm here to discuss about discrete mathematics. And from the word discrete, we get to know that discrete means separate, not continuous function. Okay, it is an analog of a continuous function. And the objects studied in discrete mathematics are integers, algorithms, and logical thinkings. And this discrete mathematics are used by the software developers. We use it in program languages and in algorithms.
And we can think that how by software developers. Software developers use this discrete mathematics in big data analytics. How? Like computers used by the software developers store large files. These files are stored in the form of ones and zeros, that are the binary numbers. Discrete mathematics is nothing but binary math. And now we'll discuss about the real life examples of where discrete mathematics is being used. First, we all use what Google Maps, right? Yes, Google Maps. How do discrete mathematics is being used in Google Maps? Google this is used in fastest to find out the fastest driving routes by compiling the smallest small routes and the technicalities, which gives the larger area report. And now discrete mathematics also is used in what scheduling time, like in hospitals, like which shift, what shift does the nurse should go, and it is also used in aviation, like this what schedule should be the flying time for the pilot. See, mathematics is used in each and every field that we have been across. And now, last but not the least, but this discrete mathematics is used in Google web researches. We all do Google researches, and Google is our best friend. How is discrete mathematics is used in Google researches? It, we research in multiple languages. It summarizes, cut shorts, and give us some data which uses logic algebra. And to expand on this topic about logic algebra, my friend Bhumika will take over.
Hello, myself Bhumika Kalasareddy. I would like to start my presentation with some quote like mathematics is it in a way that the poetry of logical ideas and it's a music of no reasons. And we all know that we all engineers and we are looking for some unknown questions and unknown problems all the time. All we need is some basic tools of algebra. And although math is a language of engineering, and I would like to ask you guys, will you like to participate in discussion like one-to-one discussion, asking few questions and queries? Are you interested? Okay. Okay, what is the main use of algebra? The main use of algebra in engineering is we use algebra for calculating the profits and loss, and we use algebra for solving the equations of engineering and to find statistics. And algebra is mainly used by civil engineers on their daily basis, and it is used to analyze and design a load bearing structures like we use as bridges, and even electrical engineers also use it. And in software engineers we use linear algebra and discrete math, as my friend Sarah mentioned briefly about it, and we also use statistics also. And these are the few insights of mathematics we used in engineering degree and which leads to our professional course. And basically I'm a data science student. I would like to discuss something about what are the job opportunities in data science by using mathematics. We use math, stats, algorithms, where we can enter in the field like data engineering and data analyst and data scientist. And we also useful for the data communication. And it's explored to all branches of engineering also. And I would like to ask you guys one question. What if we are not good at math and still we can become a good engineers? Anyone? I would like to repeat, what if we are not good at math and still we can become a good engineers? No. Why? Why can't we? Like,
We cannot imagine our life,
life without
basic
basic mathematics, ma'am. That's what I need to conclude it, ma'am, for discussing that question. But no one has participated. But still, I'd like to thank that we often take for granted all these very thing that we most deserve our gratitude. And I would like to teachers who gave these wonderful opportunities to present about the application of mathematics in engineering. They are not listening, ma'am. They are not here.
Wait, where do we go? We just move that. We just click a photo. It's not. So that. Thank you so much. So I request the online participants to motivate our students. So please be active. So I will call upon the second presenter. Triyanshu Naik and team. Is the slides are visible?
Yes, visible, madam.
Yeah, thank you. Hand over to the students. Click on to the next.
Good afternoon, one and all present over here. This is Jay Srimant, and I am going to we are going to explain our presentation on application of mathematics in our engineering. 22nd December. Yesterday, it was a National Maths Day. And remembering our Srinivas Ramanujan's great contribution to our mathematics. And now we are going to start our presentation. In graduation, we will be in our graduation, we will facing many of the mathematical questions. And if the error will come from paper to the current world, what will happen? And by this, my friend Trishanu is going to handle and going to explain about the errors if what will happen in real life.
Okay, now let's have a look at this slide. MCO versus Mangalyaan, the Mars climate orbiter. So now let me ask you a question. Why do you think this happened? Was it human error? Was it astronomical calamity? Or was it something else? The answer is very simple. It was due to mathematical error. So what they did was they used metric and SI system together, and all the calculations were off by a factor of 1.45, which resulted in the Mars circular orbiter firing its engine 1500 kilometers after it was supposed to. Now here's Gaurav, who will explain another example.
As our friend Bhumika asked us this question, what will happen if we are not good at math and become engineer? There are a few two examples like the of the MCO, and there is one example from France in 2014. If you are not getting what happened in 2014, I'll give you brief. In 2014, in France, SNCF, France State Railway Operator, found that their new high-speed railway are too wide for their almost 1,300 stations across the country. And these cost the France is the loss of million of euro. And I'm again with a question, why did this happen? And this happened due to a very minute mistake in mathematical calculation and measurement. Now we are seeing the topic importance of tolerances. Now, tolerances is something, there is a lot of point here. You can read it. I'm not gonna read all this. I'm only giving you the brief. Like, as we all know in manufacturing and building, nothing is perfect. As there is a lot of variation like temperature, pressure, and voltage, etc. Okay. And from the very first unit of our PUC, we learned that errors always add up. No matter error is minute or major, is always add up, and tolerance help us and guide us to maintain the error and make our measurement very accurate. In general, for the mass productivity, we can say that the title, the tolerance is equal to the higher productivity, higher reliability, and higher quality. Now I welcome my friend Swam to explain the real life use of matrix and determinantes to solve the real problem of our life.
Hello all, this is Swayam from AIML. I thank my fellow colleagues, teachers, and for everyone for giving me this opportunity to present this presentation today. So, math is very important in everyone's life. It might be daily course, it might be engineering, it might be any other field. Maths is like universal, like it's applied everywhere in the universe. So, maths is required for each and everything. Like if you go to a supermarket, you shouldn't get fooled, so you should be careful. We should know each and everything. So today I'll just give today due to time bound, I'm time bound, so I'll give you just a brief explanation about application of matrices and determinants in engineering. So there are a lot of applications, engineering applications from matrices and determinants. Major of those are, we use matrices a lot in civil engineering, traffic engineering and modeling, computer graphics, that's animations, digital communication, electronic networks, traffic management, and so on. So today, what is the major problem in Bangalore? Anyone can answer? Yes, exactly. So today we are going to explain how traffic management can be made easier and effective
1
using
minute.
matrices.
Your slide is not move up. Just check it out. Slides.
One slide is not moving. It says. Yeah. So this reminds me of KR market, and this is the major problem in Bangalore. So here we can see the matrices here. It's written 1, 2, 3, 4, and 5 and 6. That's just a brief example. It's more advanced in actually, but this is just example how to do it. So you can see in each road how many number of vehicles are going. So this is just a junction where a lot of vehicles are moving around. We can see here that this is just a road map kind of thing, what's going on in that junction. So here we can observe that the incoming vehicles from north are maximum. It's about 75 vehicles per minute. And the outgoing vehicles is maximum in the east, that is about 92. So here, this part of the portion of this road map is very congested and it's very busy. So we can just reverse the circle at that small point so that the movement of traffic is easier, convenient, and manageable. This will just help in traffic management. This 75 vehicles per minute and 92 vehicles per minute were calculated using advanced matrices. So similarly, you can connect a road in between of the junction to just clear the traffic easily. So from west, we can see that there are about 52 vehicles, 56 vehicles incoming, and there are about 22 vehicles outgoing in the south. So there are less number of vehicles here, which means that we can reroute the other vehicles to this junction so that traffic can be managed easily. So this is just about one example, like application of matrices and determinants in engineering and other fields. There are many more. It might be anything like animations, AI, AI assistants, voice assistants, what we use, Google Assistant, Siri, Amazon Alexa, and so on. We can calculate the number of vehicles passing through each junction using 4 variables. Like it's advanced matrices, we use 4 variables to calculate the number of vehicles passing in that junction per minute. If you have any questions, please do feel free to ask. Now I request Jai Shriman to conclude this session.
Maths has multiple advantages in day-to-day life. From watching wall clock to stock market, designing a paper boat to a cruise, everywhere we use maths. These numbers has a great contribution to see the beautiful world. Math is a backbone of science. We can't imagine human life without maths. Without maths, world can't be moved by an inch. I am here to give the conclusion of our presentation. I feel maths is the only conclusion of our life in many of our aspects. For example, figuring out how much a starter and a main course at a restaurant will cost. It helps us to decide whether that is affordable or not. We all use maths all the time, whether knowingly or unknowingly. For example, looking at watches and calculating the bus or metro when we'll arrive at our destination. These all calculations we do almost every day. Maths is a truth which you have to accept. Thank you.
Please, you should take care. The slides movement was not shown there.
Just one scroll down that PPT. We not on the audio. If possible, just 1 second slide. Oh, just 2 minutes.
just stop and then share again. We'll just see. Actually, the presentation was good.
So everything is fine. Just more enable editing and slideshow. Just put it. Then go slideshow. Just scroll down. Yeah, good.
Is this
Next,
working
next,
fine?
next. Yeah,
We'll
next,
just-
next,
We'll
next
just
slide.
scroll it.
Scroll once again, one by one. To audience, you have to see your PPT, right? Yeah.
Anyone, just
Next,
just talk for another 1 or 2
next,
minutes.
next one.
Just brief
One by
out
one,
the
you
session.
scroll down your all 11 PPTs. Yes, next.
Okay, so this was just a brief about the
Yeah.
mathematical
We-
errors.
Yeah.
Mathematical
just move on.
errors like MCO Mars climate orbiter, which was sent by NASA. It failed miserably, but Indian Mangalyaan was successful. It was just due to a small error about factor of 1.54. So, and there's another problem like France's trains were oversized. That was due to a slight miscalculation. So application of matrices and determinants in engineering. So engineering matrices and determinants can be applied in civil engineering, traffic management, computer graphics, electrical networks. Now this looks like Bangalore. So this is just a pictorial representation of how matrices can be used in traffic management. In this video, we can see a junction where traffic is flowing. And we can see most of the vehicles come from here and exit over here. So this is just a roadmap of how the traffic is moving in that junction. So this is our team, and we conclude the session by saying that maths is important in everyday's life for everyone, everywhere, and every time. Thank you.
Good.
Thank you.
Anyone have any questions, you can please ask.
Do you search what percentage of mathematics will be applying for the roadmap for finding further
I'm
traffic?
just asking a question.
You're asking for question,
Why
right?
can you
Do
repeat again?
Hello.
No,
Yes,
do you know how much percentage of mathematics you required for whatever your application show for that road traffic, right? Do you know any idea about that?
what
How much
Sorry.
percentage of the maths? How much percentage of the maths we required for computation in that engineering?
Just repeating.
Yes, ma'am. Almost like 60 to 70%. Most of it is maths. That's what I feel.
Okay. Yeah, you feel that.
Yes.
Yeah. Oh, okay. Okay. Good presentations.
Thank you, ma'am. Yes, ma'am. I answered.
Is there any queries?
I'm gonna go with next one.
Yeah, fine.
Thank you, ma'am.
Thank you for the answer. I continue. Now I'll call upon Manohar and Kumareshwar. Is the slides visible?
Yes.
Yeah. We have land out the students.
If you find mathematics as a boring subject, then code. Yes. If you find mathematics as a boring subject, then you might may learn from the wrong person. Myself, Kumar, pursuing BE in Electronics and Communication Engineering, and this is my friend Manohar. He is also in Electronics and Communication Engineering. Now we are going to explain about our PPT. We named our PPT as Aryanujan. Do you know why? Anybody? I will tell you. We named our presentation as Aryanujan. Anybody knows? Yes, you are right. That is from
In-
0 to infinity. So we have named. And one of my friends said that when he was in the Gupta era, Aryabhatta checked his paper and he invented 0. But let us move to our next slide. Once again, by remembering the Srinivasa Ramanujan, yesterday we celebrated National Mathematics Day. He was a great Indian mathematician and we lost him very early at the age of 33. Once again, I wish all maths lovers and maths faculty
Is the slides moving?
yes,
For the audience.
Yes, moving. No issues.
Yes, it is.
yes. Here Aryabhatta, the man who discovered the 0, and from 0 to infinity, that is Ramanujan. He discovered infinity, and we also call him as the man who knew infinity. We are in our team. We are only 2. That is me and my friend Kumar Manohar. And I am going to explain about biography of Aryabhatta. That is, Aryabhatta was born at 476 CE, that is Common Era, in Patliputra, present Bihar. And he was an Indian astronomer and a great mathematician that was in the Gupta era. His main interests were mathematics and astronomy. Someone asked that algebra was they asked a question about algebra, but the first one to use algebra was Aryabhatta. Aryabhatta was the one among to use algebra, and he wrote many books, and 4 of them are Aryabhatiya and Dashagitika, Arya Siddhanta, and Research Theory of Indian. The main book is Aryabhatiya. It mainly consists of Ganita Pada, that is maths and calculations. Most of the information given in this book is about special trigonometry and calculations, and it consists of 33 rules of arithmetic, algebra, and trigonometry. And it is also divided into 4 chapters, that is Gita Kapada, Ganita Pada, Kalakriya, and Gola Pada. First one, that is the Gita Kapada. It mainly deals with the cosmology and
about the Sagitaka. Second one is Ganitapada. It mainly deals with the mathematics. Only in this book, it is about calculations and trigonometry and indeterminate equations, arithmetic and geometric equations. In Kalakriya, he explained about how to calculate, how to do calendars and count the days, weeks, and months. And he said that solar year is sun's revolution and lunar year as the moon's revolution. In Golapada, it mainly cause of days and nights, rising of zodiac signs, eclipses, celestial equator, and node and the shape of the earth. Aryabhatta contributed to mathematics that only he contributed many to the mathematics, but here are the three: 0, pi, and trigonometry. He discovered zero and he discovered the zero and gave the world the digit 0, for which he became immortal. Today we remember him because of he discovered 0. Firstly, he introduced 0 in a decimal number, and then he introduced in mathematics. Earlier, 0 was represented as a dot, but when it reached to other countries, they gave it a shape oval, and today we know as 0 digit. When it comes to the pi, he discovered approximate value of pi, that is 3.14156,431, and goes on. And he also believed that planets and the moon shine by reflected sunlight. Planets and the moon shine by reflected sunlight, and the motion of the stars is due to the Earth's rotation. And we celebrate Pi Day. Do you know why we celebrate Pi Day? What is the special of March 14? Anybody? Because on that day, a great scientist and a mathematician, Albert Einstein, was born. So we celebrate Pi Day on March 14. And lastly, he gave about trigonometry. He calculated the trigonometric identities, sine, cos, inverse, and and also many inverse trigonometric identity, inverse calculations. And do you all know about full form of maths? It is about M2, yes, that is M means matrices and determinants. It comes about their own, and A means algebra, T means trigonometry, H means what I forgot that, and S means statistics. Now I hand over this to my friend Manohar.
Hi friends, this is Manohar from Bangalore Institute of Technology, pursuing B in Electronics and Communication. Here I am to tell something about the great mathematician, Sir Srinivas Ramanujan. Do you know why we celebrate National Mathematics Day on 22 December? What? Why can't we celebrate other mathematicians? Why can't others? Yes. The man who sacrificed his life for the mathematics. That's why we celebrate Mathematics Day as a Ramanujan's birthday. Ramanujan Sir Srinivas Ramanujan, he was born on 22 December 1887 in Arod in his grandmother's house. He completed his primary education in Kumbhakona Primary School and went for the town for secondary education. At that time itself, the teachers who were presented in a school recognized himself one of the talented student. In 1900, he was very interested towards the maths and doing summing on the geometric and arithmetic series by his own. After some time, he read a book named Synopsis of Elementary Results, which is written by the G.R. Kars, which is mainly based on the pure mathematics, which is one of the inspirational book for him to inspire more towards mathematics. In 1914, he made a research in mathematics and wrote most of the results in a book. When he showed this book to the British mathematicians, they rejected as a student. But when his theories were sent to the Cambridge University, they recognized his genius and recognized his talent and accepted him as a student. In 1916 March, he got an honor of Bachelor of Arts because of due to a research in highly composite numbers. He was one of the fellow who received a fellow of Royal Society. He is the second member from India and a first member from fellow of Trinity College, Cambridge. He compiled around 3,900 results. Among them are most of them are identities, equations. His notebook containing published and unpublished theorems were analyzed later part and used for the future mathematics ideas. Ramanujan was died on 26th April 1920 on. Thank you.
Manohar? Manohar and Kumar is there? Gunavati?
Yeah. Thank you for the presenters. So now I'll Manohar and Kumareshwar. So I'll call Kritika and team. So we'll be presenting on the mathematics day. Is the slides visible? Is it working with slideshow?
Yes.
Yeah, thank you. We'll hand it over to the students. So, continue.
A very good afternoon to one and all present here. I am Kritika and she is Kanika. We are from CSE Data Science Department. First of all, a very happy Math Day to all of you. I would like to start my presentation by giving a small intro about Srinivasa Ramanujan, the man who knew infinity. Srinivasa Ramanujan was born on 22nd December 1887 in Erode, Tamil Nadu. At the age of 12, he had gained the knowledge of trigonometry. At 15, he had obtained a copy of George Shoebridge's Carr's synopsis of elementary results in pure and applied mathematics. In 1911, he published the first of his papers in the Journal of Indian Mathematical Society. He was awarded the BA degree in 1916. In 1918, he was elected as a fellow of the Royal Society of London. He had spent his childhood days in great difficulty and poverty. He used to borrow books from his friends and in school, and he used to read them. When he was young, he took up the job of a clerk to meet up the basic economic needs of his family. During his leisure time, he used to practice mathematics, questions, and various types of theorems. He had discovered more than almost 4,000 theorems during his lifetime. He died on 26th April at a very young age of 32. Despite his lack of formal education and short lifespan, this great mathematician had discovered 4,000 theorems. Another interesting discovery of Ramanujan is the Ramanujan number. 1729, 1729 is also known as the Ramanujan number. When the great Indian mathematician Ramanujan was in England, he once became very ill. Professor Hardy went to meet Ramanujan at the hospital, and he said to Ramanujan, 1729 seemed to be a very dull number, and he hoped that it doesn't turn out to be a bad omen. But Ramanujan, in the contrary, he said that it is a very interesting number. 1729 is the smallest number which can be written in the form of sum of cubes of two numbers in two ways. That is 1 cube plus 12 cube and also 9 cube plus 10 cube. Since then, the number 1729 is called as Ramanujan's number, or it is also called as Hardy Ramanujan's number. Next, I would like to mention a very famous quote of Ramanujan. An equation for me has no meaning unless it expresses a thought of God. Moving ahead, I would like to mention some of the significance of the National Mathematics Day. The main motto of Mathematics Day celebration is to make people aware of the significance of numbers in life. According to Ramanujan, numbers do speak. On this very day, several schools and colleges till date organize camps and training for both the teachers and the students to enrich their mathematical skills. The National Academy of Sciences, India, every year pay homage to this mathematician with a 2-day workshop where the contributions of the great Indian mathematicians like Brahmagupta and Aryagupta were discussed. The idea cropped in 2012 by UNESCO, who agreed to sign a joint venture with India to spread the importance of mathematics throughout the globe. Dr. Manmohan Singh, the then Prime Minister of India, organized a seminar in 2012, which happened to be the 125th birth anniversary of the great mathematician who was born in Chennai. Students were informed on that seminar how India contributed to the development of mathematics right from the Vedic period to the medieval ages. Next, I would like to make a mention about some great Indian mathematicians. Aryabhatta. Aryabhatta, we all know, he was the person who discovered zero and an approximation for pi. Brahmagupta. He was the first Indian mathematician to provide the formula for the area of cyclic quadrilateral. Prasanta Chandra Mahalanobis, his most famous significant contribution was in the field of statistics. It was the Mahalanobis distance. Kalyampuri Radhakrishna Rao, who was popularly known as C.R. Rao, he is a well-known statistician famous for his theory of estimation. Narendra Karmakar. Karmakar's algorithm is an algorithm introduced by Narendra Karmakar in 1984 for solving linear programming problems. Next to mention some of the mathematicians from around the world: Isaac Newton, Archimedes, Euclid, Pythagoras, Lagrange, Gauss, Pierre de Fermat, Leibniz, René Descartes. Now Kanika would take over and make a mention about the applications of mathematics.
Good afternoon to one and all present here. I, Kanika Mahesh D from Data Science Department, would like to say the few importance of maths in engineering. Maths in a variety of career options. Mathematics is used in every area, has its own functions and its many career options. Algebra is used in study of symmetry in chemistry, networking, computer science, physics, and cryptology. Calculus is significant in biology, chemistry, the motion of water, hydrodynamics, physics, rocket science, engineering, option price modeling in economics and business models, molecular structure, etc. Significance of mathematics in engineering. The most important areas of mathematics in engineering are trigonometry, differential equations, geometry, and integral mathematics. The civil engineering depends greatly on trigonometric and geometric logics. The computer science engineering is largely dependent on numeric analysis, logic analysis, and algebra. Electrical engineering entails a lot of critical analysis, crypto analysis, operation research, and management. This branch of engineering heavily utilizes the mathematical principles, logic, formulae, and calculations. Thus, it can be concluded that in order to be a good engineer, one should be capable of handling mathematical problems efficiently. Mathematics in various university degrees. Most of the university degrees need mathematics. A few areas that include tech sciences, physical sciences, social sciences, medicine, life and health sciences, actuarial science. Different kinds of math used in computer science. Binary math, it's the heart of computer operation and among the most essential types of math used in computer science. It is used to symbolize every number within the computer. The binary number system is an alternative to the decimal system. College algebra. It covers various concepts, including linear equations, operations, factoring, exponents, polynomials, quadratic equations, rational expressions, radicals, ratios, proportions, and rectangular coordinates. Statistics. It's a form of math used in computer science that uses quantified models, representations, and synopsis for a provided collection of experimental data or actual studies. The field studies methodologies to obtain, review, and evaluate and form conclusions from data. Calculus. It's the examination of continuous change and the rates change occurs. It handles the finding and properties of integrals and derivatives of the functions. Discrete math. It provides an important foundation for all areas of computer science. Discrete math is used in Various areas including computer architecture, algorithms, computer systems, databases, functional programming, distributed systems, machine learning, operating systems, computer security, and networks.
Now it's time for a short quiz. Okay, so here comes the first question. Which is the biggest number you can make with the digits 4, 6, 7, 2, and 9? Yes, you're right. Okay, next. Where is Ramanujan Math Park located? Option A, Andhra Pradesh. Option B, Tamil Nadu. Option C, Karnataka. And D, Delhi. Tamil Nadu? Any other guesses? Yeah, you're right. Andhra Pradesh. Okay, Ramanujan Math Park. The Ramanujan Math Park is an Indian museum and activity center dedicated to mathematics education inside the Agastya campus creative lab located in Kuppam in Chittor, Andhra Pradesh. It is named after the Indian mathematician Srinivasa Ramanujan, who was from the nearby Madras state. Next, the most famous female Indian mathematician, Shakuntala Devi, was also called as, yeah, correct, human calculator. Computer. And computers. Okay, find the missing number in the series 10, 14, 28, 32, and 64. Any guesses? There's actually a simple logic applied. You can see. No? It's a repetitive logic. Someone said that 68. Yes, you're right. The series goes like +4 and into 2 +4 into 2. Go to the previous slide. Like 10 + 4 and 14 into 2 and so on. Okay, the last question, identify him. Pythagoras, yes, you're right. Okay. National Mathematics Day is a day to celebrate and recognize the importance of mathematics in our lives and to encourage students to pursue studies and career in this vital field. It is a day to appreciate the beauty and power of mathematics and to recognize the contributions of the mathematicians throughout history. I would like to conclude with a quote. The essence of math is not to make simple things complicated, but to make it simple. Thank you. Thank you. Thank you for Kritika Aunty. Now I'll call upon Akriti and team for the presentation.
Sir. ಹೌದೌದು ಹೌದೇನು ಸರ್ ಯಾರು ಎದರಲ್ಲಿ ಇಟ್ಟಿದ್ದು ಸರ್ ಇವಾಗ ಹೆಂಗೆ ಈಗ ಅಂತ ಏನು ಹೇಗಿಡ
This is all right. This is the This is all right. But we have an animation. Okay, that you want? The link on the mail. Okay. This you require, right? Yeah. Okay. Is the slides visible?
Yeah, slides are visible. Okay.
Okay. I'll add it over to the students.
Yeah.
Good afternoon, everyone. I'm Akriti.
Just wait a minute. For them, it is visible. Here it is not visible. I think it is mute. No. Okay, fine. Go ahead.
Good afternoon, everyone. I'm Akriti, and this is our team. And today we are presenting on application of mathematics in computer science engineering. And today we decided to choose this topic since it is the most relatable topic for us. Mathematics has been the bane of many students' lives. On the other hand, computer science is quite interesting and students study it in hopes of becoming the next programming expert. But it is really not that simple. And CS is in fact quite closely related to mathematics. For many years, mathematics has been much designed around computational hardness assumptions, and today we use mathematics in almost all fields of CS. For example, we use calculus in graphics designing and in application of image processing. Series expansion and multivariable calculus is used in error and approximations in computer programming. Modular arithmetic is used in cryptography, encoding and decoding. Linear algebra is used in Boolean matrix, Markov analysis. It is also used in finding critical point of a network system and optimum solution. Now my friends will talk to you about this in detail.
Good afternoon, everyone. I'm Sanjana, and I'll be talking about discrete math and programming. So we use discrete math in everyday life. Some of the examples used in discrete math are logic notation, set theory, graph theory, probability, etc. And any computation that we need to do in programming relies on math heavily. And programs written for interest calculation in banks also require math. And growth calculation in like growth in absolute terms, growth in relative terms, all use math, which are more specifically used in banks. And Boolean algebra is used in electronics, which is used to carry out logical operations on single or multiple inputs to give one binary output. And math in programming is also used to calculate the future value of currencies. For example, the value of rupee 1 10 years ago compared to now is just 0.6%. And Set theory is also used in programming. And one of the examples where set theory is used is set theory language, which was developed by Jack Schwartz. And his programming language is based on is used in mathematical and telecommunication applications. The goal of set theoretic language or programming is improve programmer speed, improve productivity, enhance program clarity, and program readability. Math relies highly on algorithms, and algorithms are basically the fundamental part of any programming. And algorithms are a set of instructions which demonstrate the implementation of a program or application. Now, I'm going to talk about how math provides the analytical skills required in programming. Being a computer science major, it highly relies on how analytical you are and how easily you can solve a problem. And some analytical skills that every computer programmer needs are detect patterns and make connections, brainstorm and theorize, integrate new information, pick between many solutions, make decision based on multiple factors. And I think all of this math provides. And if you're great in math, you're great at analytics, which makes you a great programmer. And analytical thinking helps in computer architecture, functional programming, distributed systems, machine learning, and AI. Another topic where analytics is used is statistics, and statistics is used in scientific computing, which allows computer programs to deliver accurate generalizations and predictions based on available information. And understanding statistics helps in data mining, machine learning, speech recognition, and computer graphics analysis. Thank you. Now, Khushi will take over the other topics.
Hello, everyone. Hello, everyone. It's Khushi. I'm from ISC branch. So I will be discussing mathematics is the backbone of. So mathematics is the backbone of the computer science. So as we know, computer also understand the binary language 0 and 1, which has a great connection with the mathematics. So I will be here discussing about various fields in computer science that uses like graphic designing or 3D animation, cryptography, series expansion in computer programming, and encoding and decoding using modular arithmetics. So I will be discussing graphic designing and 3D animation and cryptography. Rest will be discussed by my other friends. So calculus in graphic designing. Before the use of graphic designing in animation, we use polygons, geometry, shapes to create images. But there was a problem. When you zoom the image, we could see the edge of the shapes. So it creates a problem with it. But now we have a solution for it. Animators use parabolic functions used to create the natural curves of the natural world. A great mathematician have worked to develop different methods to quickly generate smoothly curved surface. The curved surface are often called subdivision surface because how they are calculated. By repeatedly splitting and averaging the midpoints of line. So how calculus is used in graphic designing or 3D animation? A graphic artist uses calculus to determine how different three-dimensional models will behave when subjected to rapidly changing conditions. This can create a realistic environment for movies and video games. I hope all of you like video games and like to watch movies. So there are a lot of computer programs, softwares, such as physical engines available to create the animated environment. The software we will focus on today is AutoCAD. AutoCAD is used to create the meshed models of characters and scenes before they are placed into a physical engines and made into more human-looking figures. The meshed shape is pretty much a wire outlet of character when shaded. Shows the character you intended. So next topic is maths in cryptography. The current research revealed that cryptology and coding theory are related.
The systematic block tripper standard and some hash functions are linked with MDS codes. MDS is uh, MDS is nothing but usually a message digest algorithm and a special codes encoding theory. The major mathematic fields like number theory, field theory, and coding theory plays an essential role in cryptology. So understanding of cryptography is required to develop better way to protect valuable information as technology become faster and more efficient. Some modern cryptography methods are elliptic curves cryptography, RSA encryption, etc. Cryptography, which utilized maths, was also practiced in ancient times. Some of the famous examples are cassette chipper and polyalphabetic chippers. So, next, thank you very much. And next, my friend will be discussing.
Hi, this is Dia from Computer Science branch, IoT. So we will talk about C-series expansion in computer. We'll be talking about C-series expansion in computer programming. So in computer graphics, pi and trigonometric functions play a big part in rendering. And sizing objects. The values which are used in computer graphics are not stored numbers, but they are the values which are calculated by the computer using calculus. So this Taylor series expansion is an awesome concept, not only in the world of mathematics, but also in optimization theory, function approximation, and machine learning. It's widely used in numerical computations when estimates of a function's values at different points are required. If we talk about series expansion in detail, we can approximate the value of functions at point using Taylor polynomials. A popular method in machine learning is Newton's method, which is used for finding the optimal points of a function. Newton's method used second-order polynomials to approximate a function's value at a point. Such methods which use second-order derivatives are second-order optimization algorithms. Thank you.
Yeah, encoding and decoding. So, sorry, good afternoon. I'm Shreya. So I'll be speaking about encoding and decoding. Encoding and decoding are obviously used in many forms of communications, like computing, data communications, and human interactions. Both of these processes involve changing the format of the content for easy transmission and storage. Encoding is the process of putting a sequence of characters into a specialized format for efficient transmission or storage. For example, cat can be encoded into ECV, which is obviously not how computers work, but it can be used as an example. And decoding is the exact opposite of that. It is the conversion of the encoded format back into the original sequence of characters. So, is maths really necessary in computer science? Most people say that it depends on the job. Overall, though, to pursue a computer science course, people need both logical thinking and problem solving skills and a thorough understanding of the concepts associated with maths. Thank you.
Thank you. So now I'll call upon the next batch. Ranjan PMT. I'll hand out to the students.
Am I audible?
Yes, yes, audible.
Yes. Good afternoon, everyone. Good afternoon, everyone. I think you're all so tired, right? Then fine. But I assure you that you're going to enjoy our presentation. So without wasting any more time, let's begin. Myself, Ranjan, I'm from Computer Science Engineering Department. And I'm the leader of my team. And my team consists of Harsha, Srihari, and Shashikiran. So, okay. So here it is. I'm beginning the presentation. So here it is. Our project title is Ganita Ananta. Does anybody know what it means? Huh?
Never die.
Never die. Okay. So I got some answers. For me, I think Ganita Ananta, it means math is infinite. When I say the word infinite, a person comes to my mind, that is Srinivasan Ramanujan. Everybody knows that he is popularly known as the man who knew infinity. And yesterday, we celebrated National Mathematics Day, which is the account of his birth anniversary and his great achievement and the significance of math in everyday life. So now let us see what are the contributions of Ramanujan, whether it's directly or indirectly in engineering. So this is just briefly, I put it in the slide of what background of National Mathematics Day. Now we will go on what are the contributions of Ramanujan in the field of engineering especially. So first of all, Ramanujan master theorem. This theorem is actually used to evaluate the Mellin transforms of several complex valued functions. Presently, it is used in the field of quantum mechanics through Feynman's diagrams. Secondly, theta and mock theta functions. These are actually discovered by him. And they play a very vital role in advanced mathematics and physics, like working of nuclear reactors, string theory, and quantum field theory, J variant, and even we can predict the entropy of black holes also. So now let's move on. If I go on talking about his contribution, I think the allotted time won't be sufficient for me. So I will be moving forward. So you can see here. So these are the various domains of mathematics which are helpful in engineering operations to make them easier, like namely calculus, linear algebra, differential equations, probability and statistics, trigonometry, numerical analysis, and many more. In coming slides, my friends are going to explain what are their importance in engineering. So just wait. I'm going to agree with this. Is it true? It's true, right? Will you agree with me? Math is obviously a mind game. The computational skills, analytical skills, and data handling can be solved easily with the help of math. As an engineer, it is prerequisite to have these skills, and here math comes handy. So be ready, guys, to play the mind game of math, and where you enjoy yourself, where you enjoy, engage, explore, and evolve yourself. So next.
I will tell you a story now. Or actually, it's a real life incident. You can see the quote there. I have never done anything useful. No discovery of mine has made or is likely to make, directly or indirectly, for good or ill, the least difference to the amenity of the world. How many are you from bio background here? I think. Okay. So you must be knowing about Hardy-Wimber principle, right? Yeah. So this is the case. Hardy had never expected that, or he always expected math to be pure, means devoid of any practical applications. And he was proud about them for not being applicable to anything. But ironically, most of his theorems are used in genetic engineering, cryptography, and other branches of physics. So what's the moral of the story is like, whatever you try to keep, whatever you try hardest to keep your mathematics as pure as possible, but destiny will somehow apply your mathematics in important real life things. So these are some of the textbook concepts or the results and the theorems which we will come across in our curriculum. So I'm just briefing about them. I'll just brief about them. First one is Taylor series. It is actually used to understand them. It is used to evaluate or understand the small variations or small variations over a range of input values to the system. Then Fourier series. It is used in the analysis of signal and system processing in particularly electrical and electronics engineering. Next, regular-Falsy method. In this, we are going to differentiate the system input and control output by using the equations. Means we are finding the root of an equation and we are going to get the solution for that. Then fourth one is Newton-Raphson method. It is used to find out the relationship between electrical current and voltage in the system. So I just brief about these concepts. We will come across or we will study in details in upcoming years. So what we came to know that math and engineering moves hand in hand. Now I'm going to call Harsha, who is going to talk on what are the mathematical applications in various engineering streams and technology. So over to you, Harsha.
Okay, so hey everyone, myself Asha KL from CSE Data Science Department. So today I'm gonna explain how math is being used in currently society and how much it adds value in every tech field and all. So I to explain this, I go through each and every tech field where maths is being used, and without maths, how maths is valued in that particular tech field. Okay, as alphabets begins with the letter A. So I'm going to take up a tech field. Alphabets begins with the letter A. So I'm going to take up a tech field which going to begin with letter A. Any guess? A tech field which begins with the letter A. Yeah. Yeah. Artificial intelligence and machine learning. So for a building to be stand strongly, the foundation must be strong. In AIML, the foundation of this tech field is representation of data and its related computation on machine learning. For this foundation to be strong, there is a mathematical concept which make this foundation strong, that is linear algebra. So hence they say without linear algebra, there is no AI and ML. Further, the linear algebra is used in dimensionality reduction and converting data into vectors, and it is also used to describe operations of algorithms. Moving on to next, and another tech field called robotics. An interesting tech field where a mathematical concept called geometry is being used to solve the problems related to kinematics of robots, like how
force and torque affects the robotic motions, and it is also used to analyze mechanism of robots and creating 3D models in programming, which is later converted into real life objects. Moving on to the next and another tech field called cyber security and trending tech field. It is trending, as we all know. Nowadays, the rate of cyber crimes is getting increased. So to overcome this problem, we need to keep data safe and protective. For this, we need to create and route data every second in binary format. So this is where a mathematical concept called cryptography comes into picture. It ensures the user to access the encrypted data in the environment of many network interfaces. And also, let me take an example. Like we all heard about IP, Internet Protocol. It helps the user to access an encrypted data, and it encrypts the application software data of networking devices. Moving on to the next, blockchain technology. It is a database mechanism where a technology is used to create an interface between many business networks, and it allows to share information between them. So here where the mathematical concepts called cryptography and game theory comes into existence. So to keep data safe and secure the integrity of blockchain and all, the application of cryptography is used in this blockchain technology. And on the other side, the game theory is being used to provide an interface between the user and the blockchain and allow the communication between them. The main concept of the blockchain technology is this. So they say if there was no game theory, then there would be no blockchain technology. Moving on to the next, IoT, an abbreviation of Internet of Things. The mathematical concepts like probability, statistics, and Boolean algebra are used in this to analyze the data and to learn the machine workings and for the security purpose and to control the systems, optimization, and etc., which is used to create IoT systems. Where further, like these are the main mathematical concept which is used in this IoT. The other mathematical concepts such as numeric theory, mathematical algorithms, algebraic abstract, etc. are used in this IoT. So now I call upon my friend Srihari to explain other tech fields in which mathematics is being applied.
Good afternoon. Myself Sherry from CSC Data Science. So far my friend has explained about various fields in computer science engineering like cybersecurity, Internet of Things. But what is the core of all these computer science? Any guesses? What is the core of all computer science? Like what is the core of computer science engineering? Like computer science engineering is more in software, but there should be a core for computer science engineering, right? Any guesses? What could be a core for computer science engineering? Core. So yeah, it's electronics. Without electronic integrated circuits, computer science, any computer cannot work. So I'll be taking you through various applications of mathematics, electronic fields such as electronic fields. Any guesses? So far, my friend has explained about this most of the technology and embedded with technology. So do you have any guesses like what I'm going to explain? I repeat, he's embedded with more of technology. So do you have any guesses like what him? Yeah, it's embedded systems. So embedded systems is a field of electronics which mainly uses trigonometry for navigation position of objects and uses calculations from optimization principles and uses linear algebra for matrix multiplication for image and video processing. Moving on, very large scale integration, which is abbreviated as VLSI, where trigonometry is used to represent and analyze signals, and calculus is used to determine the rate at which output changes with respect to input in circuit, and uses probability to determine the likelihood of failures in the circuit, and uses linear algebra, which includes translation matrix to manipulate layout of the chip. And the most important graph theory, which is used to optimize layout shape. So moving on, all of us would have come across global positioning system, which is GPS, which takes us safe in remote places. So even mathematics is used in GPS. There are two main principles such as triliteration and Kalman filtering, which is a mathematical principle. So triliteration, which involves measuring the distance between the device and 3 or more GPS satellites and using this information to calculate the device position. Kalman filtering is used to improve the accuracy of the device location by taking into account various sources of error, such as atmospheric effects and satellite clock drift. Moving on. UPI and QR code, which is very simple. We use it every day for our transactions, like digital transactions. We use it every day. And even here, mathematics comes into the picture. So simple mathematics such as basic algebra transactions, like without even knowing basic algebra, when I have to send 5,000 rupees, if I include another zero, it will be 5 lakh rupees. So there would be a problem. So basic algebra is must here. And another high-level concept as code encryption and decryption using number theory and probability are also used in UPI for smooth transactions. So moving further, so silk technology, like you would have seen your parent, your sister, mother, who would be wearing beautiful silk sarees and you would have admired them. But to have that beautiful silk sarees, silk technology plays a role where precise calculations and measurements for weaving and dyeing is required, and statistics and probability are required to ensure quality control of a fabric, measuring various garment properties such as length of the garment, the thickness of the garment, and the quality of the garment. Okay, so moving on, all my friends have explained the applications of engineering in a very known fields such as electronics, computer science, mechanical, and civil. But I would like to mention about the unique fields in engineering, such as chemical engineering, aerospace engineering, mining engineering, and marine engineering, where maths plays a very important role. Coming on to mining engineering, trigonometry is used in mining engineering to design layout of mine and to map survey sites. And calculus is used in mining engineering to find the stability of slopes and design the machine equipments of mining. And probability is used in mining engineering to calculate the probability of stresses and a change in conditions in the mine sites so that mining engineering goes on smoothly. Next, coming to aerospace engineering, all of us are very known of the aerospace projects which are going on. And aerospace engineering is like rocket science. Everyone would say, use a common metaphor like it's rocket science. Actually, it's not rocket science. It is the most advanced mathematics which is used in aerospace, which we call it as rocket science. So rocket science, which is aerospace, it uses calculus to find the geometry and aircraft and spacecraft. And it uses trigonometry to find the motion and object behavior of motion and object of behavior and of fluids. And it uses linear algebra to design the control systems within the aircraft or the spacecraft. Coming on to the most budding engineering field, which is marine engineering, which will take a big toll in future, where there would be lack of water, and marine engineering plays a huge role there. So marine engineering applications in mathematics is trigonometry is used to design and find direction of ships and marine taking into consideration the different marine phenomena. And calculus is used to model motion and forces acting on the ship for the smooth performance of the ship and smooth propagation of ship on the ocean. And graph theory is used in marine engineering to find the relative position of ships. And like most of the naval architecture and most of the naval armies use this graph theory, which is a part of marine engineering, to find the enemy or the submarines beneath the ocean and to track the security of the nation. And normal geometry is used in marine engineering to design shape of the various components of the ship so that the ship doesn't fail. Coming on to the next, which is chemical engineering, which is basically the pure science, but some engineering applications is much required in chemistry studies so that chemistry as a pure science can be taken to a different level. So in chemical engineering, trigonometry is used to find the oscillatory phenomenon such as angular momentum and angular velocity of the different chemical reactions taking place in the reaction, and uses calculus to model and analyze transport phenomena and energy balance, and uses linear algebra to find eigenvalue decomposition and single value decomposition. So moving on, I call upon my friend Shashikiran to give his insight about world without mathematics.
Hello, everyone. Have you ever wondered what the world would look like and feel like without the concept of maths? Well, let me give you an example. Imagine this. You are on your way to your home and you notice your vehicle is running low on fuel and you decide to go to the nearest petrol bunk and you say to the man, Sir, ಒಂದು 500 ರೂಪಾಯಿ petrol ಹಾಕಿ. He stares at you for a few seconds and asks, Sir, ಇಷ್ಟು petrol ಬೇಕಾ ಅಥವಾ ಇಷ್ಟ? So this is what happens if you remove math out of the picture. Because the concept of money, volume, and rate would not be present without mathematics. So is it easy to take big steps towards development without mathematics? Obviously not. Let us see a few examples. So this is the incident that happened on January 28, 1986. NASA had just launched their rocket and had crossed their fingers. Just 73 seconds into the flight, the space shuttle exploded mid-air. So after close examination, it was found out the shuttle booster seal had a leak, which allowed all the hot gases to escape, and this in turn ignited the main fuel tank, which stored the majority of rocket fuel. This cost USA millions of dollars, months of dedication and hard work, and mainly the life of all the crew members in that shuttle. If only the mathematical model was built more precisely and accurately, the entire situation could have been avoided. Now, this is another situation. This happened on July 17th, 1981 at Hyatt Regency Hotel in Kansas City, USA. Basically, there was a program and people were having a tea dance on the second floor walkway. Suddenly, the walkway collapsed. This accident killed about 114 men, women, and children, and more than 200 were injured. This happened because the walkway could carry only 462 people in terms of weight, but the number of people dancing on it were more than 1,000. Now tell me, why would a good engineer build a walkway that can hold only 462 people but give space for more than 1,000? It was clearly a design flaw. So now, mathematics carries not only 4 credit points in an exam, but also it is important in our real life for the sustained and everlasting growth of mankind. Thank you.
So we conclude that mathematics plays a crucial role in engineering as it provides a language for understanding and solving problems related to the design and analysis of engineering systems. Many engineering innovations rely on the use of advanced mathematical techniques, including optimization, differential equations, linear algebra, and probability theory, to name a few. Engineers can tackle a wide range of unsolved innovations, develop energy efficient, and contribute towards sustainable development by adopting the elementary mathematical principles and techniques. Engineering would seem to lack basic foundation if mathematics did not exist. A small mathematical error in biotechnology would cost hundreds of lives, kill thousands of people walking on a bridge, disrupt the whole circuit, lead to hazardous accidents in factories. So, maths is elementary and very important in engineering. Though mathematics might feel tough in engineering course, but engineering would still be an amateur without maths. So, can we have a huge round of applause for maths for helping us in engineering? Thank you.
Thank you. I'll call upon Dr. Rupa Madam to conclude the session.
Hello. Can I hear me? Please
Yeah, ma'am.
unmute.
Audible.
Yeah. Yeah, our first year students, first semester students, they joined 1 month before. Uh, we we thought we are giving an opportunity for first semester students for this PPT presentation. But those who are participants, means our colleagues, you please appreciate all those who are given a PPT presentation for this today. At least they tried the maximum level for what we are not expecting that much, but somebody they given, overall they given very nicely. At least why we are giving this type of opportunity for the students is they entered only 1 month before, not even 1 month, I think maybe 25 days before. They has to know how to do the PPT presentation, means they has to refer some model journals and Google, everything. At least they have a practice, and also they knows how to present in front of audience, and also how to prepare PPT also is very much important. For this reason, we are given to the chance to the first semester, but we already given chance for fifth semester students in the last year. That's why we are calling only first semester students. Those are coming from other college and our college to participants, means faculty, our colleagues. We have to encourage the suppose. I think everyone we are happy with what they given PPT presentation for our site students. See, and also see, sometimes you believe it or not, even though I'm having a 31, 32 years experience, some 1 or 2 concept, not even I know that they search a very good way. I'm so appreciating our students. They maybe do very good presentation and very good thing in next further future also. Thank you very much for all what they participated for this event. Once again, and thank you for everyone. And also I thank Dr. Gunavati and Dr. Bhanushri and then Dr. Maya. They evaluated, they sitting from 2 o'clock to 3. They evaluate, and also they did back end work also. They prepared everything, released everything. They given so much idea for that. And also those are joining online. Uh, those are our college participants, means our colleagues. You please come and visit tomorrow 9 to 12 our exhibition. Those are not they are outsider, means don't worry, we are taking videos. We are going to share it in our group. At last I'm telling that as a mathematics faculty, without mathematics, you don't have a life in engineering. That is not only engineering, everywhere, even the finance or MBA, MCA, everywhere. Without mathematics, daily you want to start, you go for 1 liter milk, you are telling how much rupees. See, if you want to send your any kid like a first standard, second standard, you are giving 20, 30 rupees. They're going to do the, why you are sending the first standard, second, or sometimes UKG kid, we have to learn the mathematics addition and subtraction. Sometimes they are not bringing correct change. You are telling you have how much rupees in your hand, how much are given, how much rupees is taken. You subtract it. He is going. See, I saw last year in my cousin. She given one chance to his son. She given, I think, 50 rupees. Go and buy for half a liter some red color milk. He came back so with less amount. She told how much amount are given. You first write it, and then how much per liter he told. You subtract it, you come back, she told. After 5 minutes, he came back. No, this much I want to take it back money. Yes, that person is not given, that uncle is not given correctly. Again, he went back, he's bring it correct change. They used what actually mathematics. If I'm telling everyone, mathematics very, very important. Even though nowadays mathematics, yesterday we conducted 2 talks, both are mathematics background only. My opinion, suggestion is, suppose anyone strong in mathematics, easy to understand your whatever other software codes also, what you have, Java, Python, everything. Therefore, maths must be strong. Then you have to learn anything, even though you go for what about this one, medical field also, first year they have compulsory statistics. They must be because there so many doctors, they contact me to publish a paper based on corona or based on dengue. They taken a decision based on testing of hypothesis. Therefore, everywhere without mathematics, suppose you give a conclusion that is not effective to the other end. We can once you apply the mathematics and plotting a graph, everything within the graph only we are easy to communicate other end. That's why maths is totally. Strongly I'm saying that maths is very, very important. Therefore, without maths we can't lead life smoothly, properly. That's my opinion. Maybe it's possible some one or two cases for your hardware. Not required. Hardware also is not required. Means some calculation, some you do anything there also required mathematics. So therefore, based on that, I'm going to wind up this. Thank you very much for those who are offline. They are sitting, some of our students, some faculty, and also online. Thank you very much for everyone. We are supporting for our students, and then we are supporting our program also continuously. So most of them, I know from 2020, still they are supporting for me. I'm expecting further also. I'm planning to conduct in January Python and Python with Python. I'm going to share it. That with nominal fees, you through online, you please register and join that. Thank you very much. I'm going to hand over to Gunavati madam. Okay. Yeah, you please wait. We are waiting.
Maya, please do share the feedback link.
Participant, I share the feedback link in chat box. Please fill it.
Also, if you have any comments, suggestions related to the presentation happened today, please do share that. Tomorrow's
We provide a suggestion in that feedback link. You can provide it in that feedback.
Yeah, for the tomorrow's session, ma'am already told it's an offline session. So the recorded video will be posted in the WhatsApp group. Even the yesterday's and today's session, it is available. So if possible, we'll upload the tomorrow's also into the YouTube, and we'll share the YouTube link with all these 3 days. So we'll try our best. The YouTube, is it possible that tomorrow's recorded video? Otherwise, that the video and these 2 days, we'll share the YouTube link. Thank you all for your cooperation. So we'll just stay back just to get the link. So later, if you fill the link, you can leave. Thank you all.